Hi everyone, in this video we're going to start talking about arrays. So before we get started talking about arrays directly, let's talk about a real-world application, which I have here, a book. Now, if I asked you how would you look up a certain chapter in a book, you would say, well, I'll go to the table of contents and I will see what page it's on, and then I can flip to that page. And that's exactly what we're going to do. So, for example, I already know, having looked up, that arrays are described on page 19 of this book. So all I do is I open up the book and I start looking at the indices once we get to the actual numbered pages. Okay, and so I see here, okay, great, I'm on page 7. Okay, and so I know if I just flip through and keep going, I'll eventually get to page 19. And in fact, it does talk about arrays on here. So that's good. It also talks about loops on here, which I didn't know, but I was able to, because I knew the page number, just flip directly to that page. And it was actually quite easy to do so. And that's basically what we're doing with an array, is we're using indexing to be able to look up certain values. So now that we have that example with the book and using a book to look up page numbers, let's talk about what arrays mean in computer science. Arrays are a data structure which store a fixed number of elements of the same data type. In other words, like it's a collection of data types. Here's an example. An array of the days of the week would be Sunday through Saturday, and since there are 7 days in the week, it's 0 through 6 are the indices. Okay, so I have these two words here, index and element. Let's talk about what they mean. The first word, index, is the location inside an array. So I can say index 3, and you could actually look it up and you would know that it was Wednesday. And Wednesday is the element. The element is the data stored in the array at that index. So I told you, let's look at index 3, and you tell me the element at index 3 is Wednesday. That is the data. Let me move on and talk about indirection. Indirection has to do with how to access your array in the memory. So let's suppose, for example, that you have an array of ints. We know that an int is 32 bits long. So if you declare an array of length 7, which is what this is, and you say it's of int, then you'll get a contiguous block in your memory. And because it's ints and there's 7 of them, you know it's going to be of length 32 times 7 bits. Now, each element is the same size, and now for indexing, remember I said, look, we just need to look up, like you can just say to me 3, and I'll tell you that the element at that index is 5. But where it actually is in the memory looks a little bit different than that. The index for the ith element is given as start plus 32 times I, because 8 is going to take up 32, 6 is going to take up 32, 7 is going to take up 32, and then by the time I get to the third element, it's going to be 32 times 3. That's where it's going to tell me where 5 is. I think this is like maybe a little bit abstract to think about where things actually are in the memory addresses of a computer. It becomes more important later on when you actually start using memory directly. But for now, we just need to understand that when we talk about my array at index 3, there's actually a specific location that the computer is looking up relative to the size of the elements of the array. Okay. Actually, the book example helps, I think, to understand indirection a little bit better. I know, for example, that I'm going to see arrays on page 19. And so when I flipped open the book and I randomly flipped it open, I see that I'm at index 40 or page 40. I only need to flip back pages to get to page 19. And when I do that, I don't need to count words. I just flip back pages. That's actually quite convenient because I know I kind of have a sense of how long each page is, right? But it's not like I'm counting words to get there. I'm not even really counting pages. I'm just flipping through a reasonable amount of pages to get to the page that I want to go to. So the reason that we want to declare arrays is so that we can store a lot of data, and we don't need to have individual variables for each of them. So with the days of the week, I would have day 1, day 2, all the way up to day 7. Now, 7's not so bad, but let's think again about my book, which is a couple hundred pages long. I don't want to have a variable for each page. Maybe I just want to store it so that I can look things up easily. The way that this looks in Java syntax is like this: data type, open and close brackets, and then the variable name. So that is the template for how you'll declare an array in Java. For example, if you had the days of the week that we've been talking about, it'll be string, open and close brackets, days of week is the variable name. And so far, I have not instantiated days of week to be anything, I just declared it. Now, there are a couple ways to actually assign the values. The first thing that you need to know is if you don't know what will be added into the array at the declaration time, but you do know its size, then you can go ahead and declare a new array object with the size. So for days of the week, let's just assume I don't know the days of the week, but I do know that there's 7 of them. I'm going to say string open close bracket days of week is equal to new string open and close bracket with the word 7 inside. So remember this keyword new because we're declaring a new object. That new string 7 allocates 7 blocks in memory for strings that will be added in later. So by doing this, I talked about those contiguous blocks of memory. Here we can see that Java already knows that there needs to be 7 blocks available. So we've made our array. Now how do we fill it? So we do know the days of the week. I've declared these contiguous blocks. One way to do this is to just go by indexing. Days of week at 0 is Sunday. Days of week at 1 is Monday. And so on until days of week at 6 is Saturday. So now days of week is actually instantiated with each of the values. A slightly faster way to do it, because I know all the values, is to use these open and close curly braces. So string open and close bracket days of week is equal to open curly brace and then each of the elements separated by commas. Sunday, comma Monday, comma Tuesday, and so forth until Saturday. And just to show you here, because I didn't want to write it all out, this ... refers to writing those other words out. This is equivalent to writing out each of the days of the week and saying the index. So days of week at 0 is equal to Sunday is the same thing as having the first thing in your little curly bracket list be named Sunday. Okay. You may have already started to realize how you access elements in an array because it is actually very similar to the way that we instantiate those elements if we know if we go by index. So we're going to use square brackets to access the elements. If I've already set up all the days of the week, I can actually do system.out.println days of week, and then in brackets I can put the number 3, and it will actually tell me that the third day of the week is Wednesday. There are other ways to use it because you might want to set a variable according to an index. For example, you might want to say string temp is equal to days of week at 3. And so you'll notice here, even though days of week is an array, that days of week at 3 is a string, which is why it's okay to set it equal to assign it to string temp. Now, one thing is arrays are complex data types, so you can't just print an array. So if you try to do that, it'll just tell you the memory address. And so this is just a string representation of the data's memory address, this like at 659E0BFD. If you actually want to print out each of the elements of an array, you will have to use a loop. Now, one way to print out individual elements of an array is with a for loop. The syntax for the for loop looks like this: for, and then in parentheses, an initialization. In this case, I have int I is equal to 0. Then I have some sort of stopping criteria. So as long as I is less than 100, we can go into the loop. And then finally, we have the increment, which is what we would do after each cycle of the loop. And then inside your curly braces, you can have it print out the ith element of that array. Now, previously, we have talked about while loops. And with while loops, we had this initialization outside the loop. The condition was inside the parentheses of the while loop, and then the increment was inside the loop body. All of that is going to move according to the syntax of the for loop. Int I is equal to 0, the initialization, I is less than 100, and then I++ will all live inside the for loop statement, inside the parentheses, and the loop body will be moved inside the loop body of the for loop. Now, more or less, you can use for loops interchangeably with while loops. In general, you should use a while loop as an indeterministic loop, meaning running until something isn't true, and a for loop you should use as a deterministic loop. In other words, you know explicitly that you're running it n times. That doesn't always have to be the case, but in general, this is the way that you would want to use things. There's also, I should briefly mention, there's also the do while loop. And the do while loop is something that you want to run until it isn't true, but you know it's going to run at least once. So kind of up to you in terms of which loops you like and which would make more sense in the context of your program. Okay, with all of that in place, let's talk about traversing an array. Now, arrays have a .length feature. When I declare string days and I just set it equal to the days of the week, it already knows that this is going to be of length 7. So days.length is going to be 7. Now I could put that in explicitly, or I can in the loop just say I is less than days.length. And you'll notice here the indexing is I is equal to 0, I is less than 7, I++. Because remember, my array is indexed from 0 through 6. So rather than printing out the memory address, which is what you would do if you just tried to print out the name of the array, if you do a loop, you will actually get the individual elements of that loop, which is probably what you want. Another thing to remember is that strings are going to use .length, which has parentheses, and arrays use .length, no parentheses. So this is probably something that you will mess up over time, but please try to remember if it's not working, it's because you've mixed up whether you have parentheses after the name.length or not. Cool. So at this point, there's I think you know enough to be able to do some practice problems. So with each of these, as always, you can pause the video or work on them on your own time to make sure that you've understood what we've talked about. All right, the first thing to know here for this problem is once an array is created, its size cannot change. So here I have int mylist 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know that index 0 through 9, these are my indices, are going to have the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this code, though, says, what is my list at 20? And you know, 20 doesn't exist. So my question for you is, what's going to happen in this code? If you try to run this, what will Java do? We've talked before about methods. I do want to point out that, like passing any other data type, you can pass an array as a parameter inside a method. So here I have this thing called standard deviation, and you'll notice that the input is actually an array of ints, which is specified as int open close square brackets list. And so just like a traditional parameter, it acts as a placeholder for the value. So now you can use list inside your method, and you can do anything that you could do with an arrays inside your method. So just to point out some things here, this is what's called a for each loop, which we haven't talked about yet, but it allows you to iterate through the elements of the list. And you can see it's average plus equals element, so it's just summing up all the elements of the list, and then it's going to just take the average at the end of the loop, which is average is equal to average divided by list.length. Now, you can also return an array from a method. So you can see here I have public static int and then open brackets reverse. So this actually returns an array of ints. And then some work is done inside here to actually reverse all the elements of this input array, which is just called array, and it's just going to return that reversed array. Okay, so for this one, this method here and the previous one, I think a good way to practice would just be to type out those two methods and then to practice with a couple of different examples to see what the output of these methods will be. The last example that I have here is something called a linear search. If I give you an element, which is called key, in an array list, you can output the first occurrence of the element in the array. So I will step through an example just using random numbers. So I'm going to create an array list with random numbers in it. I'm going to pick some number to look for and see if it occurs, and then I'm going to output that number. You are welcome to pause the video and try it out yourself. Otherwise, you can work through with me step by step. Good. So whenever we start our program, we're going to have this main, of course. And now I'm going to create this array list, which is int open brackets list is equal to new int. I'm just setting it to have length 100. Then I'm going to populate the array with random numbers. And once I've done that, I'm going to traverse the array. To populate the array, I'm going to have to use a for loop. And since I know it's of length 100, I'm going to have int I is equal to 0, I is less than 100, I plus plus. And then inside my loop, I'm going to have list at I is equal to just a random math.random times 50 and cast to an integer. So that's just going to give me random numbers 0 through 49 inclusive. And I'll just pick 25 as the key that I'm looking for. So whatever you picked here, when you were writing this, doesn't really matter. The point is the logic. And then the key index that you have is -1, because I don't know where the key currently is. Now, to traverse the array, Well, we already know how to traverse an array. We actually did it above when we did that loop. We're going to do another loop, and inside my loop, I'm going to check, is list at I equal to the key that I'm looking for? If it is, then I'm going to set key index to be equal to I. And by the way, I don't have to keep looking, so I can break out of the for loop now. Good. Now, at the end of this loop, either you found it or you haven't. So if the key index is not -1, you will say the index of the key is at whatever index you found it to be at, and otherwise you would say, well, key index is equal to -1, and therefore that element is not in the list. So as always, I highly recommend you type this out, give it a try with a couple of different maybe sizes of arrays and a couple of different key values and see what happens. And I also think another good thing to try on your own would be to write this separately as a method that takes in two parameters, which are key and list. But for now, that's all I have for you. Thank you for watching.